Bioplastics, an alternative to petrochemical plastics in prosthetics. So what exactly is a prosthetic? It is a device that substitutes for a missing or defective body part to allow for a greater quality of life. The history of prosthetics can be traced back thousands of years ago in Egypt, where the first ever recorded prosthetic was a toe made out of wood and leather. Throughout history, different types of prosthetics were created for varying purposes and from different materials. In ancient Rome, prosthetic arms were made from iron and bronze. Later on, prosthetics were even found amongst pirates and sailors who would create peg legs and hooks for hands, helping to inspire one of Disney's most evil villains. Prosthetics became more functional with the addition of locking mechanisms that allowed for better control and movement of the prosthetic. They also started to look more like limbs they were replacing. Besides improving the actual limb, medical procedures that included prosthetics, such as amputations, improved as well. Modern-day prosthetics have a wide variety of components including aluminum and other metals, plastics, and electrical devices. Each component is chosen to make the prosthetic more durable and more flexible, the two main necessities of a functional prosthetic. In order to achieve these specifications, a prosthetic piece must be modified and remodified until it reaches a desired shape. Thermoplastics, which are plastics that can be heated to a malleable state and reshaped without losing its properties, are perfect for prosthetics that require constant reshaping as bodies tend to change. Wouldn't it be nice if these thermoplastics could just come right out of the ground and all you had to do was pluck your favorite prosthetic from the soil? But that'd be crazy! Unfortunately, we all know plastic doesn't come from the ground. Or does it? Well, in reality, plastic itself doesn't come from the ground, but the materials used to make it does. Crude oils are extracted from the ground through a process called fracking, which pumps pressurized liquids into the earth to fracture it. This allows petroleum and natural gases to flow easily to the surface. Once this oil is brought to the surface, it is refined through a process called cracking. Cracking separates the contents of the petroleum and breaks them down into monomers of hydrocarbons. These monomers are then processed into different resins, ultimately becoming the plastics we're all familiar with, which are then shipped out to different companies that use these plastics in their products. So what's the problem? Why is making petroleum-based plastics a bad thing, and why should we care? Well, to start, the methods of obtaining the oils from within the earth requires a lot of machinery. Some must drill deep down into the ocean floor, which is where problems tend to occur. The most harmful of these problems that we all hear about is oil spills. Even if one part of the machine malfunctions, the ocean can quickly become polluted, which will kill any marine life that comes in contact with it. This is not an easy fix since it is so far below the surface, but by the time it can be fixed, the environment's already a wasteland. The other more important problem is that petro-based plastics are not biodegradable, therefore they can become toxic to the environment. What does this mean? Biodegradation is a process that starts with an organic source that can be extracted into raw materials and then manufactured into a product. When discarded, the organic waste can then be broken down into CO2 and water. According to IUPAC, this is biodegradation. However, there have been recent innovations in the plastic industry that have created things called bioplastics. What are bioplastics? No, they're not organisms made of plastic. They're actually plastics that are derived from biochemical reactions within the cells of a living organism. Now, most bioplastics are presented as biodegradable, but that can be misleading because a majority of bioplastics are only partially biodegradable. What does this mean? Partial biodegradation is when part of a material breaks down into CO2 and water, but other parts are not biodegradable and can become recalcitrant and toxic to the environment. This is sometimes worse than not being biodegradable at all, because these small toxic molecules can proliferate throughout the environment at greater rates. What you need then is an environmentally friendly alternative. The best known bioplastic that fits this description is polyhydroxyalkanoate, or PHA. PHA is considered as the only bioplastic that's 100% biodegradable. Furthermore, since it's produced from bacteria, it does not need to be extracted from the earth using fracking or drilling, thus eliminating the biohazard. In order to produce PHA, Bacteria must go through fermentation, which can be done at an industrial level inside fermentation tanks. This process involves using a hydrocarbon source, which can come from waste products such as municipal wastewater, cardboard, paper, and malt waste. Using waste product is beneficial because you're not only removing the waste from the environment, but you're using it to create a product. During the fermentation process, the bacteria will feast on the hydrocarbons and convert them into storage molecules for energy. These storage molecules happen to be PHA. After that, it's a matter of extraction. Extraction can be done in a number of ways. They all involve lysing the cell with chemicals to remove the PHA from within. A large amount of organisms are capable of producing PHA, but it has been found that bacteria, specifically the Enterococcus species, produce the largest amounts. However, there is always potential for a species to be found that may produce an even larger amount of PHA. Today, PHA-based products are mainly being used in the packaging industry, which is wonderful, but the potential is being wasted. While it is uncertain where PHA may be going next, what we do know is that it should be used for prosthetics, because it provides a cheap and environmentally friendly way to give people proper healthcare. And when that prosthetic needs to be discarded, instead of sitting in a landfill, it can be safely degraded instead. It just makes sense.